Okay, I'm hoping to give you a brief rundown on implicit differentiation, which is a method of differentiating relations, not just functions. We use it for functions too. So let's look at some of the theory. Okay, this is theory by using examples. If we want to differentiate 2x cubed with respect to x, I think you can all do that. That's going to be 6x squared. You can see here, I've changed the x's to y's. The derivative of y, 2y cubed with respect to y is 6y squared. Here we've got a different situation. Our variable is y, but our variable differentiation is x. So one way you could think about it is I really need to differentiate this with respect to y, because y is my variable. So if I do y dx times dy, if I cancel out the dy's, I'll just have dx. So that's the same idea. So dy dx times dy of 2y cubed is the same as will give me the answer I'm looking for. So derivative with respect to y of 2y cubed is 6y squared, and then I've got to multiply x. Okay, that's one way of viewing it. We can also do this as a function of a function. This is the chain rule. It's the derivative of the outside, which is this, and times the derivative of the inside, which is 2y dx. So you can think of it as fractions to be cancelled out, or think of it as the chain rule. Basically, when you've got a variable that's different to your variable of differentiation, you have some other kind of derivative. For most of us, that'll be dy dx all the time. So for this example, we've got a variable y differentiating with respect to x. So we're going to multiply by x. So that'll be 16y cubed dy dx. Same with this example. Firstly, I'll simplify it a little bit. So we're differentiating 12y to 2 with respect to x. So I get negative 24y to the negative 3, and I multiply that by 2x. Here's another two examples. This time I've got a product, x, y. So I've got to use the product rule. The product rule says it's x times the derivative of y plus the derivative of x times y. Now if we simplify that, derivative of y with respect to x is just dy dx. Derivative of x with respect to x is just 1. So that's our answer. Alright, here's another product. So again, use the product rule. So 3x squared times y to the 4th. So product rule will be 3x squared times the derivative of y to the 4th. It's derivative of 3x squared times y to the 4th. Okay, 3x squared stays there. Derivative of y to the 4th is going to be 4y cubed times 2y dx. Derivative with respect to x of 3x squared is 6x. Okay, and just simplifying that to finish off. We could take out a common factor if we want, or definitely 3 times 4 is 12. Okay, here's a more complicated example, an applied example. Determine the gradient of this particular line here. Sorry, this particular curve, this particular relation. Okay, two ways you can do it. The old way we've done it is called explicit differentiation. Sorry, explicit differentiation, where you worked out what y is. There's y. Here's the quotient. Use the quotient rule. X, and substitute in x. Now, you're using a few different processes there, which, you got squares there, so it's easy to make mistakes. So an alternative method, same question, this time we use implicit differentiation. Find dy dx, that's the gradient. So we take with respect to x on both sides. Now that left-hand side, we break it down into three different terms there. Okay. Derivative of negative 2 is 0. Derivative with respect to x of 4x is negative 4. Which is 4, sorry. Derivative of y with respect to x is dy dx. Derivative of xy with respect to x, well, we did that on the previous page. There it is. See here, we've got dy dx. That's what we want. So we rearrange, take out a common factor, and we divide, we get dy dx equals that. Different to what we had on the last page? Sure. But if we substitute our values in for y and x up here, same answer. So I think that's both quicker and easier, and it's only one process really instead of three, and less chance to make a mistake, and a good example of how we can use implicit differentiation to get an answer. It's explicit and we have to use implicit, so this is a good example where you could use either, but implicit's the best idea. Right, another example coming up. Okay, here's an example from our textbook from Houston Harris. Okay, find the slope of the tangent to x plus y cubed equals 4y and y equals 1. Okay, so that's a nice relation there. So slope of the tangent, that's dy dx. So use our implicit differentiation. Sides there of each term. Derivative of x with respect to x is 1. Derivative of y cubed with respect to x is 3y squared times dy dx. Derivative of 4y with respect to x is 4 dy dx on both sides, so we'll simplify and factorize, get dy dx equals 1 on 4 minus 3y squared is 1, and put that in, and the slope of the tangent is 1. We can check that using the graph of the relation. 1, that's going to be here. That's our tangent, and you can see that that's 1. Easily, it looks like 1, and it is 1. Okay, hope this was helpful. See you again.